Hello everyone. We have been discussing about limiting reagent, and today we will discuss two problems on limiting reagent that will help you to understand the topic more clearly. Okay, now here is the first problem. If 40 gram of calcium carbonate is heated with 40 gram hydrochloric acid, which of the reactants will act as limiting reagent? Okay, for this you need to write down the chemical reaction, balanced chemical reaction, but in most of the question the chemical reaction will be given, but in this question chemical reaction is not given. You have to write it down. Okay, so first the chemical reaction, that means reaction between calcium carbonate and HCl. So when calcium carbonate and HCl react, then calcium chloride and water and carbon dioxide is formed. Then you need to balance the chemical reaction. There will be 2 hydrogen and there will be 2. Okay, now this reaction is completely balanced. Now you need to find out the limiting reagent. Okay, to calculate to identify the limiting reagent, you have to use the reaction stoichiometric calculation. Okay, so before going to the given data, first we will write down the reaction stoichiometric. So now 1 mole of calcium carbonate, here 1 mole of calcium carbonate reacts with 2 mole of hydrochloric acid, gives 1 mole of calcium chloride, 1 mole of water and 1 mole carbon dioxide. Now in this question you don't need to calculate all these things, because here you just need to find out the limiting reagent. So only taking the reactant question can be solved. Okay, now 1 mole of calcium carbonate, so you need to calculate the molar mass of calcium carbonate. So for calcium, molar mass is, so molar mass is, how to calculate? For calcium 40, for carbon 12, there are 3 oxygen, 3 into 16, so 40 plus 12 plus 48. Okay, the answer will be 100. So molar mass of calcium carbonate is 100 gram. That is, molar mass of calcium carbonate is 100 gram. Okay, now again you need to calculate the molar mass of HCl. So again for HCl, for hydrogen 1 and for chlorine 35.5, that is 36.5, but here 2 mole of HCl, so 2 into 36.5, so you need to multiply it with 2. The answer will be 73 gram. So here that means 100 gram calcium carbonate reacts with 73 gram HCl. Okay, and you don't need to go for calcium chloride, water or carbon dioxide, because you just need to find out the limiting reagent, which can be done by taking the reactants only. Okay, you don't need to go for calculation involving product, because to find out the limiting reagent we only need the value of reactant. So now using this stoichiometry, that is 100 gram calcium carbonate reacts with 73 gram hydrochloric acid, you can calculate the limiting reagent. Now given data, so now you need to, according to reaction stoichiometry, we need now for calcium carbonate and HCl. So for 100 gram calcium carbonate we need 73 gram HCl. It is for 1 mole calcium carbonate we need 2 mole HCl. Now given 40 gram calcium carbonate and 40 gram HCl. Okay, now only using this data we can calculate the limiting reagent. Now how to calculate the limiting reagent? So first we will write like 100 gram calcium carbonate reacts with 73 gram HCl. Okay, so 1 gram calcium carbonate reacts with 73 divided by 100 gram HCl. Now in this question we have 40 gram. So now 40 gram calcium carbonate reacts with 73 divided by 100 into 40 gram HCl. Answer will be 29.2 gram HCl. Now see here, 40 gram calcium carbonate reacts with 29.2 gram HCl. That means for 40 gram calcium carbonate to react, only 29.2 gram HCl is required. But in this question HCl is given 40 gram. That means HCl will be left over in this reaction. Okay, and all calcium carbonate will be consumed, because for 40 gram calcium carbonate you need only 29.2 gram HCl, but you have 40 gram of HCl. That is, you have enough HCl to react all 40 gram calcium carbonate. That is, calcium carbonate will be completely consumed. That is why here limiting reagent will be calcium carbonate. Okay, because all calcium carbonate will be consumed. Okay, clear? Now this is the first numerical on limiting reagent in this class. I hope it is clear to you, and we will move on to next one. Okay, so now this is also a very important question. Iron can be obtained by the reduction of iron oxide according to the following reaction. Okay, in this question reaction is given. Now you are asked to calculate how many kilogram of iron oxide FeTO4 would be heated with carbon monoxide to get 2 kilogram of iron. Again we will use the same stoichiometric calculation. Now here reaction is given. FeTO4 plus 4Cu goes to TFe plus 4CO2. Okay, now in this question the reaction is given in balanced format. Okay, you don't need to balance it, but you should at least once check whether it is balanced or not. So now again we will use the same stoichiometry. It is 1 mole FeTO4 reacts with 4 mole carbon monoxide, give 3 mole Fe and 4 mole carbon dioxide. Now we will calculate in terms of gram. That is, we need to calculate the molar mass of all the substance here. Okay, now molar mass of FeTO4. So FeTO4 for iron it is 56. Molar mass of iron is equal to 56. So 3 into 56 plus there are 4 oxygen, 4 into 16. and answer will be 232 gram. Now 1 mole of FeTO4 is equal to 232 gram. Okay. Now molar mass of carbon monoxide, simply for carbon monoxide you can calculate like for carbon 12, for oxygen 16, it is 28. Okay. Now in this case there are 4 mole of carbon monoxide, so 4 into 28 gram. Okay, and TFE, that is 3 into 56, okay, and into 56 gram, and 4 carbon dioxide. And for carbon dioxide molar mass for carbon 12 to oxygen 2 into 16 is equal to 12 plus 32 is equal to 44. 4 into 44 gram. Okay, that means 232 gram FeTO4 reacts with 4 into 28 gram carbon monoxide to give 3 into 56 gram Fe and 4 into 44 gram carbon dioxide. Okay, now in this question we need to calculate how many kilogram of FeTO4 should be heated with carbon monoxide to get 2 kg of iron. That is, in this case you don't need to find out any limiting reagent because you have enough reactant to produce 2 kg of iron. Okay, you don't need to go for limiting reagent because there is no mention about the amount of reactant. Only you need to calculate, that is, amount of reactant required to produce 2 kg of iron. Okay, so here you only the stoichiometric calculation, you use only the stoichiometric calculation to find out the amount of FeTO4. Okay, that is, we will use only this value FeTO4 and Fe. Okay, and 3 into 56 is equal to, will be equal to 168 gram. That is, you need to use this data and this one. Okay, because here you need to calculate FeTO4 to get 2 kg of iron, 2 kg of Fe. Okay, only these two data will be involved in this question. So according to reaction stoichiometry, you can write 168 gram iron is produced from 232 gram of FeTO4. That is, 1 gram iron is produced from 232 divided by 168 gram of FeTO4. Okay, just use the unitary method. So according to question, to get 3 kilogram, whether it is 3 or 2, it is 2 kilogram. Okay. So to get 2 kilogram, okay, again you need to write down in gram. Okay, so to get 2 kilogram iron is produced from 232 divided by 168 into, because 232 and 168 are in gram unit, so 2 kilogram will be 2000 gram. So we will use this value in gram into 2000. Okay, unit in gram of Fe. Okay, now the answer will be 232 into 2000 and divided by 168. 2761 2761 gram of FeTO4, or in kilogram 2.761 kilogram of FeTO4. So you can simply calculate the amount of FeTO4 required, okay, by using this simple stoichiometric calculation. Okay, now you can see the question here. You are asked to calculate the mass of FeTO4 to produce 2 kg of iron. For that, first you need the balanced chemical equation, which is given in this question already. You only use the reaction stoichiometry. Okay, this is 1 mole, 4 mole, 3 mole and 4 mole. Okay, now you will calculate in terms of gram, that is you need to calculate in terms of molar mass, that is 232 gram of FeTO4 reacts with 4 into 28 gram of carbon monoxide, gives 3 into 56 gram of 56 gram of iron and 4 into 44 gram of carbon dioxide. But to solve this question, you need only two data. One is FeTO4 and another is Fe3Fe. So only using these two data you can solve this question this way. Okay, so I hope you understand the limiting reagent concept. Okay, in my next class we will move on to next topic. Okay, thank you.